Hello, I am Daniele Wolfart. I will present a paper about modernizing legacy systems with microservices, a roadmap. Legacy systems are long-lived applications with obsolete technology and degraded architecture, hampering digital transformation and making innovation more difficult. However, legacy systems represent important technology and have great value for business. To remain competitive, companies have been modernizing legacy systems, migrating to a modern architecture or platform. One of the strategies that has been used to modernize legacy systems is by the adoption of microservices. Microservices became popular because their adoption by big players, as for example, Netflix, Uber, and Amazon. With microservices, complex applications are built as a suite of small, loosely coupled, and autonomous components that encapsulate business capabilities and communicate with each other by using language-agnostic APIs. Some advantages of microservices are reduced maintenance and evolution effort, independence for teams, facilitate the inclusion of innovation and scalability. Despite the growing interest in modernization with microservices, there is still a lack of comprehensive study on how to conduct such modernization. Existing work generally does not take into account the organizational and operation perspectives of modernization, focusing mainly on the technical aspects of microservices. In addition, existing studies focus mainly on process-specific activities. Based on this, companies lack a roadmap of real-world scenarios, covering the entire modernization process and dealing with organizational, operational, and technical aspects. So, the goal of this study is to present a roadmap of a process to conduct the migration for guiding practitioners on modernizing legacy systems with microservices. As our goal is to define a roadmap from the existing literature and answering this research question: why and how are monolithic legacy systems migrated to microservices? So, we considered the driving forces that motivate the modernization, the why, and common activities together with input and output information, the how. Our study followed a methodology based on systematic mapping and consists of three steps: the selection of primary sources, data extraction, data classification, and roadmap definition. We extract this information from 62 primary sources. Now I present the result. We have identified 11 driving forces to modernize legacy systems with microservices, divided into three types: operational, technical, and organizational. There isn't a dominant driving force that is mentioned in all papers. Differently from some studies advocating mostly for technical benefits of microservices, for example, use of different technology, we can see that supporting operational tasks are the most common driving force to adopt microservices. We defined a roadmap composed of 4 distinct phases with 8 activities of modernization of microservices, as shown in this figure. We also define inputs and outputs for each activity that will be presented below. As expected, the earlier activities receive far more attention than the later ones. This indicates that research on the topic of modernization of legacy systems with microservices is still in its early stage, highlighting the need for further studies. Now we are going to see the activities. The first activity is analyze the driving forces. In this first activity, companies have to clearly identify and understand the limitations faced with the legacy system. Based on such limitation, managers, engineers, developers, and in some cases, the customer as well, can reason and decide if a modernization with microservices is a feasible solution. At this point, these stakeholders of all perspectives can foresee the benefits of modernization and how long it will take to achieve them. This activity is paramount to avoid problems and waste of resources. As input artifact, we have driving forces, business goals, and resources available for conducting the modernization. As an output artifact, we have decision on conducting the modernization of the monolithic legacy system with microservices. The second activity is understand the legacy system. The goal of this activity is to analyze and explore the legacy system, to understand its implementation, its features, and how these features interact with each other, and how the monolithic legacy architecture is organized. This activity is essential to the next one. The activity number 3 is decompose the legacy system. This activity aims to break down the monolithic architecture into small and cohesive units, which will be transformed into microservices. The decomposition and identification of microservices in monolithic legacy systems is acknowledged as one of the most complex activities of the modernization process. Some authors recommend that the identification of microservices should be an incremental process. They argue that due to the complexity of this activity, practitioners will learn how to do it better for each microservice decoupled from the legacy. An important issue in the activity of identifying the microservice is the definition of their correct level of granularity, that is, the trade-off between size and number of microservices. As input artifacts, we can see the output of the previous activities, desired non-functional requirements, and APIs specification. And the output artifacts, we can see microservices candidates or identify microservices. The activity number 4 is define the microservice architecture. This activity is responsible for defining a microservice-based architecture with the design decision to meet functional and non-functional properties defined in previous activities. In a sample view, a microservice architecture describes the microservices, their APIs, and communications, which is usually done by using a lightweight protocol. For example, HTTP RESTful. Here, practitioners also have to define a strategy of service discovery. In this architecture, the user interface, business logic, and databases are packaged in a single application and deployed on a server. The activity number 5 is execute the modernization. The goal of this activity is to conduct the modernization by re-engineering the monolithic legacy system into microservices. Microservices reduce the development complexity in comparison to monolithic architectures. However, for the modernization that relies on existing artifacts, this can lead to more effort in comparison to the greenfield projects. As input artifacts, we have available technology and tools developers and engineers experience. As output artifacts, we have microservices implemented according to the defined architectures and transition documentation. The activity number 6, we have integrate the microservices in the legacy. This activity is responsible for the integration between microservices and the legacy system. As the modernization with microservices is an incremental process, practitioners have to decide on how to put together the legacy and the modernized parts of the system. This is one of the least explored and briefly discussed activities in the primary sources. As we discussed in previous activities, architectural choices need to facilitate continuous delivery and deployment during the modernization. The activity number 7 is verify and validate the microservices. This activity focuses on verifying and validating if the microservices were developed properly and the integration with the legacy was performed accordingly. This activity uses the legacy system as vehicle for testing tasks. Considering the continuous integration environment, unit tests are accepted to be created during the implementation of microservices. But in addition, black box integration tests are also required. As input artifacts, we have the output of the previous activities, usually constraints, non-function requirements, among others. As output artifacts, we have unity and integration tests and black box functional tests reports, metrics about satisfaction of non-function requirements, and microservices ready to deploy. And the last activity is monitor the microservices and the infrastructure. This activity is devoted to constantly check the behavior of the deployed microservices. Monitor the microservices and the infrastructure should focus on service availability, performance, use of the infrastructure resource, and so on. Here, practitioners are able to evaluate and analyze information of the modernized system in comparison to the driving forces that motivated the modernization. As conclusion, we have the modernization of monolithic systems with microservices is a trend that has drawn the attention of the software engineering research community. Due to the inexistence of many studies on this topic, and with most of them focused on specific points of modernization, this paper presented a study based on the systematic mapping method to answer the research question, why and how legacy systems migrated to microservices. And the answer was given based on 62 studies. We found 11 different driving forces that motivate modernization, that is, answering why companies decide to migrate. In addition, we explain how this is done, dividing the process into 4 phases and 8 activities. As feature work, we consider the validation in the industrial context. More studies focus on less investigation activities, namely execution of modernization, integration of microservices and legacy, verification and validation, and monitoring of the modernized system and infrastructure. We also see the opportunity to develop tools to support modernization. Thanks for your attention, and I am available to clarify any questions.